So in this video, I'm going to explain what we have done in the previous part. So over here in BP camera, our logic will first start from here, that is the event begin play. And in this section of logic, we are basically getting the reference for the BP save game over here so that we can actually retrieve the save.g store characters that is stored in here. So we are using the save.g store characters in the for each loop, which will determine the maximum distance at which the camera can move at the right side. So this whole section of logic over here will basically do just that. So over here we are first getting the move camera by x value over here, and again in our variable section over here under move camera by we gave a value of 200 in the x-axis, and we are adding that value to the maximum write distance. So for each character that is present in the save.g store characters, it's going to add 200 to the max write distance. So if we have 3 characters, it's going to add 600 to the maximum write distance over here. And that means the camera will move 3 times to the right side. And after that 3 times, you won't be able to move any further to the right side. Again, I will demonstrate how this works when we actually add some new characters into our data table in a few minutes after I explain the remaining logic. And again, this bunch of logic we already explained it in the previous parts of this tutorial series. So then we have this 2 section of logic over here, and this 2 section of logic will be executed when we press the left or right button in our store blueprint widget. So for the write custom event, I have first subtracted a value of 200 from the max write distance. And the reason why we are subtracting 200 from the max write distance is because over in here in our for each loop, once again we are adding a value of 200 to the max write distance for each and every character that is stored in the save.g store characters, and that includes our mail runner. And because of that, our camera will be able to move past our final character in our store level, and that can be an issue because there is no character over there to select. And to prevent our camera from moving past the final character, I'm adding this 200 over here. So for example, if I were to remove this 200, just give it a 0 over here, and that means we are not subtracting any value from the max write distance, and compile this and try running the store level. Alright, so if I were to click on the right button over here, our camera is able to move past the final character, and this is a bug in our game because it's undesirable. We don't want our camera to move past our final character, and it is for that reason I'm giving a 200 over here. So if I were to try this out again, you can see our character is not moving to the right anymore. Continuing on to our write custom event, over here I basically replaced the previous value that was over here with a common variable called move camera by. And the reason why we are using this move camera by variable over here is so that it's easy for us to change the distance between location A and B very easily by modifying this single variable. And that is the reason why we are using a variable over here. And again over here, it's again the same reason. The only difference over here is that we are multiplying the value of the move camera by x value by -1. And the reason why we are doing this is basically to reverse the position. So basically by multiplying 200 with -1, you get -200. And using that you can actually go backwards. So when you click on the left button, you can move the camera backwards. And then coming back over here, in the box trace by channel, we are first getting the return value to the branch over here. And the reason why we are doing this is to check whether we have hit a character or not. So if we hit a character, it's going to execute the true pin over here and then continue on this whole section of logic over here. But in case if we didn't hit any characters, like we saw previously when we were testing the right button, then it will execute the false pin and then create this error message that I'm releasing as a print string so that we can know that something went wrong over here. So in case the return value is true, it will run this for each loop, and from the for each loop, it will first compare the hit actor, that is the class of the hit actor, with the store characters over here, and then it will compare whether the two of them are equal or not. So this is a way for us to retrieve whatever character that the box trace have hit. So if the hit actor's class is equal to the class in the store characters, then it will execute the true execution pin in the branch node over here. And once it executes the true execution pin, then it will retrieve the character name and the character array index of that specific character that the box trace is currently looking at. And in case you are wondering what we are going to do with these two variables, basically we are going to use this variable in the store blueprint widget and then store these two data in our save game. And the reason why we are not storing the character name and the character array index directly over here is because each time our box trace over here hits a character, it is going to execute this whole section of logic over here. So we don't want to constantly keep saving the character name and the character array index into our save game each and every time our box trace hit our character, especially when that character that the box trace have hit isn't the character that the player is trying to use currently. So instead of trying to store the character name and the character array index, we are actually going to store these two information in the store blueprint widget. So specifically in the select button, we are going to be creating a select button to select a character in our store level, and we are going to save the character name and the character array index when we click the select button instead. So this way we don't need to constantly keep saving the character name and the character array index into our save game. And now to demonstrate the benefit of having these changes in our BP camera, we need to actually go to the store characters over here, and we need to add some characters over here. So just for demonstration purposes, I'm going to create two extra characters over here just for demonstrating how this BP camera actually works. Alright, so I created these two data over here. So now we need to go to the content browser and then navigate to store characters over here, and then I'm just going to duplicate this cube runner over here. So right click and select duplicate, and we are going to duplicate another cube runner as well. Just for demonstration, I guess we could try changing the color of the cube. Back to our data table, make sure to add those two store characters. And that's it, save it. Go back to the store level, and if I were to try running this right now, you would notice that none of the characters have spawned yet. Our store characters array haven't been updated yet. To update data in our store characters array, we need to first delete the previous save game, then return, and then go back to the store level. Now over here, if I were to go to the right side, you can notice our cubes have spawned over here, and notice that our cube is not moving to the right side anymore. With the new changes, our BP camera is able to dynamically change and adjust the max write distance, or the distance at which the camera can move to the right, without having to manually adjust the values anymore. So this can be very useful when you have a bunch of characters in your level, like 100 or 200 characters. It's going to be beneficial to have this kind of logic in your blueprints. So yeah, that's about it. Thanks for watching and see you later. Bye.